Look at this video here. It's a video on decimals. We are going to discuss add and subtract decimal numbers in this video. It's video number 17, part 2 of 3. I have divided the video in 3 parts and this is the second part. Let's continue here. And let us continue. Okay, let's continue to the next section here. Okay, so it's a decimal. We all talked about decimal numbers, what those are. Now we are going to talk about how to add and subtract decimal numbers, and in the following section we will discuss multiply and divide decimal numbers. Let's continue. Okay, let's recall some observations from so far in the previous section. Okay, let's recap the previous section here. Okay, a decimal number has actual or implied decimal points. So there is a decimal point, either it actually exists or it's implied. There are digits to the left and the digits to the right of that point. For a pure fraction, we usually use a 0 to the left of the point. For a whole number, there is an implied point and a 0 after that. Okay? A decimal number results from division by a natural base number. Okay? Decimal number is a fraction, usually a mixed fraction, and comes from division just like the common fractions do. Let's continue. A whole number comes from a division by 1. A decimal number can be represented by coefficient and exponent. That's we studied already, where coefficient is a whole number and exponent is a power of 10, where 10 is a base number. Further, power of exponent is negative of number of digits to the right of decimal point. Okay, power of the exponent is negative of the number of digits to the right of the decimal point. Let's continue with the recap here. This is what we already studied before. A decimal number can be represented by coefficient times the exponent, where coefficient is a whole number and exponent is a power of 10, where 10 is a base number. Further, power of the exponent is negative of the number of digits to the right of decimal point. Okay. Let's continue here. We can add zeros to the right of a number with the embedded decimal point. Okay. If a number had an embedded decimal point, we can add zeros to the right of that number without affecting the value. Okay. By adding zeros to the right of such a number, gives me another number which is equivalent. Okay. And we obtain that we add zeros, that implies that we are doing the multiply and divide by 10. Okay. When we add a 0 to the right of a number containing decimal point, then we are multiplying and dividing by 10. Okay, so that means we are getting an equivalent number that multiplies the coefficient by 10 and subtracts 1 from the power of the exponent. Okay, so that would multiply the coefficient by 10 and subtract 1 from the power of the exponent. Let's consider some operations with decimal numbers. Add, subtract. In a video on algebra, in this is the video, we had argued that if flags match, we can add, subtract. We can add, subtract the coefficients. Okay? In that case, we perform the operations on the coefficients. Okay? So add and subtract we performed on the coefficients. Okay? Let's continue. So let's do example. 5003436 plus 2140902. Okay? Okay. So I can do a number splitting here to make it easier. Okay, we split the number in here, 2 digits, 2 digits, 3 digits, 2 digits, 2 digits, 3 digits. Okay. Then we say 500 plus 214 is 714, 34 plus 9 is 43, 36 plus 2 is 30. So add these numbers together and I got a 7144338. Okay, let's continue here. Question: which decimal point in the example? We were looking for decimal point. Is the decimal point in here? Okay. answer, there is 1, an implied decimal point, and 0 to the right of the whole number. This is a decimal number with the implied decimal point after the 6 and a 0 after that. This is a decimal number with the implied decimal point after the 902 and 0 after that. Okay, let's continue. So now we'll talk about adding decimal numbers. Okay, so how would we treat numbers with actual decimal point? Okay, let's see. Consider. Let's add these numbers together. Consider 89236 decimal 70 plus 8052 decimal 23. Okay? Here, this is 89236 decimal 70 is equal to 8923670 times -2 second power of 10. Okay, and this number is 80522380522 times negative second power of 2, 10, negative second power 10. And this is my exponent form of the decimal numbers we had. We studied the exponent form in the previous section. Okay? Let's continue here. So it's just like algebra here. Flags match. Both flags are -2 here, and this is the coefficient 8923670, and this is another coefficient 805223. So it's like we add the coefficients like we studied in algebra video, and we kept the flags here. Flag was exponent value was 10 raised to power -2. Okay, so again we can add them up using our number splitting again. 70 plus 23 is 93. 52 plus 35 is 87, and 892 plus 80 is 972. Okay? So let's go 972, 87, 93, and exponent is still the same, 10 raised to the power -2. Let's continue, and that is 97287.93. Okay? It's like 97287.93 divided by 100, and when you divide by 100, decimal point just come in here, the 2 digits to the left of rightmost digit. Let us continue here. What did we do here? We first converted the exponent form. From there we applied lesson from video on algebra. Okay? And that lesson was if flags, which is power of the exponent, this one, and this one, match, we can add the coefficient, which just we did. Okay, let's continue. Let's add numbers again. Do we have to convert to an exponent form? Question. And no, you can add decimal numbers directly. Do we need to watch for anything? If we were going to add them up without converting to exponent form, what is there something we need to be careful of? Okay. Yes, before adding, subtracting, you need to ensure that the flags do match. Okay. So let's look in here. It's a 20736.56 plus 79698.36. Flag value is -2 for this monomial, this term, and also for this second term. One operand has flag value -2. There are 2 digits to the right of the decimal point, and the other one also has a flag value of -2. Flags do match. Okay. Now we can just add them up. 20736.56 plus 79698 decimal 36, and so 56 plus 36 is 92, 36 plus 98 is 134, 7 plus 6 is 13, 14. So we have 79 plus 20 is 99 plus a carry 100. So we get 100434.92. Okay. So when the flags did match, we didn't have to convert. We just say add the numbers together and kept the decimal in the same place where it was in the operands being added. Okay. Let us continue here. Okay. So this is what we did in previous on previous slide. Okay, what did we do? Verify that flags match. We did say -2 here and -2 here. Okay, add it as if we were dealing with whole number. We just didn't, when during adding, we just didn't care for the decimal being there. We just added as if there are whole numbers only. Okay, and after that kept the position of the decimal point. Decimal point was to the 2 digits to the left of it, the rightmost digit, and that's we kept that. That's my flag value. Let's go do this example here. What did we do now? Verify the flag match as well as add as if it were dealing with the whole numbers and kept the position of the decimal point, which is a flag value. Okay, now we're going to do this example here. Let's say flag value is -1 of the first operand and -2 of the second operand. Let's continue here. So 80522 decimal 3 plus 36331 decimal 43. Okay, now can we add just like the previous example? Okay, flags do not match, so we cannot easily add the numbers together. Okay, do we see any problem? What are the flag values? -1 for the first operand and -2 for the second operand. For the first operand, flag value is -1, and for second operand it is -2. We cannot add the coefficient as if they are like we did in previous example. So we have to make some adjustments. We cannot straightforward add these numbers together because the flags do not match. Okay, let's continue here. So this is our example here. So this is what we were asking. Can we add just like the previous example? Answer: do you see any problem? Okay. So there are -1 and -2 flag values. So we cannot add the coefficient just like we did in previous example, but we still have to add them. Okay. How can we match the flag value? Do you remember what we did in the previous section? We were able to change the flag values. Okay. By multiplying and dividing by 10 repeatedly if necessary. Okay. Flag value is -1 here and -2 in the second operand. So for first operand, we'll multiply and divide by 10 repeatedly if necessary until we get a flag value of -2. Let's continue here. We can do that easily by adding zeros to the right of the decimal point. Okay. First, we know that if we add a zero to the decimal right of points, its a value doesn't change, but its a flag value does. Okay. It's equivalent value, equivalent number, but a flag value does change. That's what we studied in the previous section. So now we're going to add a 0 here, and so we've got 80522 dot decimal 30, 80522 decimal 30, and now I have flags value match. -2 for the first operand and -2 for the second operand. Now we can add. Okay, so 8 plus 3 is 11, 5 plus 63 is 68, 22 plus 31 is 53, and 30 plus 43 is 73. Okay, so that is equal to 116853 decimal 73. Okay, we started with example where flags didn't match. We made them match by adding a 0 to the right of the first number. Okay, and then we can add it. Okay, let's look at another example. 7955 decimal 423 plus 3866 decimal 13. Flag value of second operand is -2 and the flag value of the first operand is -3. So flags do not match. We have to make them match. And what we do is we add a 0 to the right. This new number is equivalent to the first number, initial number, but this one has a flag value of -3. First number also has a flag value -3. Now we can add. Okay, 79 plus 38 is 107, and 55 plus 66 is 121, 1 gets carried to the left. On the right side, 423 plus 130 is 553. Continue here. So that's after we resolve this carry here, the number becomes 108 21 decimal 553. So that's equal to 10821 decimal 553. Let's continue here. Okay, another example here. 6177 decimal 126 plus 4360 decimal 527. Flag values match here. Minus 3 is for the first operand and minus 3 is for the second operand. Let us continue here. So when we add them together, it's with number splitting again. 61 plus 43 is 104, and 77 plus 60 is 137, and 126 plus 527 is 653. Let's continue here. So that's equal to 104 here, 137 here, and 653 here. 26 plus 27 is 53, 1 plus 5 is 6, 77 plus 60 is 137, 1 gets carried, 61 plus 43 is 104. Let's continue here. After we resolve the carry, it's a 10537 decimal 653. We added these two numbers together, flags matched, 6177 decimal 126 plus 4360 decimal 527, and the answer is 10537 decimal 653. Let's continue. Observations. We align the decimal points. So what we did is we align the decimal points here. Okay. Added zeros to the right for convenience. When there is a need to, when the flags do not match, we add zeros to the right, and that's just for convenience. As soon as you align the decimal points, we basically have a matching flag. Added the operands and kept decimal point. Okay, so that's what we did. Take this number together, press this number, add 0 to the right, so that there are 3 digits to the right of decimal here and 3 digits to the right of decimal point here. Adding a 0 to the right of a number containing decimal point is an equivalent value, and it comes from multiplication and division by 10. Okay, then we can add them together as if they were just whole numbers, but we need to keep track of the decimal point where it is and keep it decimal point same place. Same thing here. Now, the digits to the right of decimal point is 3 here and 3 here. Flag values minus 3 here and minus 3 here match. We can add. If they didn't match, we, like in here, we just align the decimal point and add 0 for convenience, and add the operands and kept decimal point, just in this example here. Let us continue. Continue and do a subtraction using decimal numbers. Okay, let's continue here. Question: how do we subtract decimal numbers? Okay. Answer: we have already learned that we treat decimal number like a whole number with decimal point. Okay. For addition, if we align decimal points, we can add the two numbers. In algebra video, we learned that we can add and subtract the monomials, which is single term, if the flags match. So this is we are using that lesson from algebra. Okay. If decimal numbers, in decimal number we do have exponents which and flags. Okay. Exponents have flags. Okay. Let's continue here. We match the flags by aligning decimal points. Okay. We match. For addition and subtraction, we match the flag by aligning the decimal points. Let's do examples for subtraction. Here this is example. We have 66546 decimal point 73 minus second operand is 45498 decimal point and a 3. There are 2 digits to the right of the decimal of the first number, and there's only 1 digit to the right in the second number. Okay. Continue. So minus 2 is the flag here and minus 1 is the flag. Now we add a 0 to the right. Now there are two decimal positions after decimal here and two after decimal in first number. So flag values now do match. Now we can subtract. So 66 minus 45 is 21. 546 minus 498 is 048. And 73 minus 30 is 43. Let's continue here. It's 21048 decimal 43. Let's continue. Example 85721 decimal 08. And we're going to subtract 20802 decimal 31. Now we can subtract. We say 8 minus 2 is 6. 5 minus 0 is 5. 7 minus 8 is negative 1. 2 minus 0 is 2. 1 minus 2 is negative 1. And 0 minus 3 is negative 3. And 8 minus 1 is 7. Now we have negative number here and negative here and negative here. Okay. Let's resolve the negative numbers and see what comes up. So first of all, 51 here, 5 positive and 1 negative is 50 minus 1, which is 49. So 649. A 2 here positive and a negative 1 and negative 3. These three numbers together make it a 200 minus 13. That is 187. So 18 decimal 77. Okay. So 85721 decimal 08 minus 2082802 decimal 31 is 64918 decimal point 77. Okay. Let us continue here. Observations. We align decimal point. We just aligned here. Okay. We align here. Okay. Right here, line decimal point here. Okay. Aligned here. Add zeros to the right of for convenience. We added 0 here for convenience here. Add the operands. Subtracted the operands here. So we are doing subtraction, so we subtracted the operands and kept the decimal point. Okay? We subtracted the operands and kept the decimal point. You can do some exercise here. Some add 7907 decimal point 417 plus 28193 decimal 36. Okay, let's continue here. 34890 decimal 09 plus 19495 decimal 25 and some more. Okay, now we're going to subtract something which is 1882 decimal 869 minus 62 decimal 6843. Let's continue. 75432 decimal 89 minus 45309 decimal point and 10 and some more. Let's look at references. The first reference I use is Vedic Math Teacher's Manual 1, Volume 1, which is a elementary level by Ken Williams, and this book is available from vedicmaths.org. PDF form is free. The book does not have a section on decimal numbers, but it's assumed that you can use the techniques described in the book for decimal operations. Let's continue here. Vedic Maths by Bharti Krishnaji. This is the main primary reference on Vedic math, and it covers all the topics in Vedic math. And the book may not have a section on decimal numbers, but it implies that user is familiar with decimal numbers or can use the other techniques described to compute the user decimal numbers. Okay, let's continue here. Discover Vedic Math by Ken Williams. This is the most complete, authoritative, and with consistent notations. The book is organized by sutras. So this should have section on decimals. Okay. Let's continue here. Vedic Math for School in 3 volumes by James T. Glover. Mr. Glover used these books in his school. These are easy to read, very complete, not as complete as Ken Williams' book is, but it's very complete and contains significant geometry. So if you need to learn geometry too, as is taught in schools, this book is a very good reference. Okay, let's continue.